So volume requires that you use the height that goes up the inside. So really quick, pencils down, let's just try this. Does this give you the height that you want for volume? Yeah, it goes down the inside into the middle. Does this one give you the height you would want?
No, yes.
So what, yes?
No.
No, good. Because that's not going up the inside. The height for volume has to start at the point and has to go straight to the other edge at a right angle. Well, how would you find the height now that you wanted?
Oh, I know. You use a or
Pythagorean theorem would be quicker, yeah, because you don't know any angles. Which one's the hypotenuse?
12.6
Squared equals 8 squared plus 4 squared. And you would solve that, okay? This one, does this have the height that you would need for volume? Yes, it starts at the point, goes straight down. Does this one have the height you would need?
Yep.
Yeah, starts at the point, goes straight to the base at a right angle, right to the middle. Does this one have the height you would need? No, good. You'd have to draw it from the base, from the vertex down to the middle. And what would the hypotenuse of this blue triangle right here be? 10.6. And then equals 5.5 squared plus the height squared. Okay, so there will be a few problems where you have to find that missing piece before you can do the work. 5.5 squared plus the height squared. Does this one have it?
No.
No. You would have to draw it to go right down here. The height has to be drawn to the middle. That's essential. Now this one's a little bit different. What's the hypotenuse?
10.5.
5. But what are the other two sides? One is h squared. What's this?
That could be so it's only halfway.
That's right.
5.5.
Excellent.
Hey, when I got it, feel
11 all the way across. 5.5 is halfway, which is where the height came to. So you would have to work that like that. We'll have some like that later, but I just wanted to quiz you on that. Okay, so the formulas. It's the same as yesterday, except that the volume is going up to a tiny little point, which means it's getting smaller. So every time it does that, you take the volume and you divide by 3. So the base shape is just dependent upon whatever is across from the vertex. This is your base right here. You find the base area just like yesterday, and then you divide by 3. The height has to be the one that goes straight to the base. It cannot be on the surface. And for the cone, it can be the same thing, but the base in a cone is always a what? Circle. And some people like to automatically put that in the formula. Base area would be pi r squared. So some people just use that as their formula. Pi r squared times the height, and that's fine.
So to find the volume.
So if we think of it that way, the base is a circle with radius 8. From now on, I'm going to not worry about pi to the very end, because it makes a more accurate answer than rounding. I'm going to show you the difference in a second. Base with a radius of 8. Circle. What's the formula for base area when the base is a circle?
Pi 8 squared.
Pi r squared. It's a circle. So that's pi times 8 squared. And we write that as a squared is 64. 64 times pi. Now, we have to choose volume. So volume, since it goes to a little point, it's not a cylinder that goes straight down, it's cut. We have to cut it. Base area times height divided by 3. So now you just have to plug in the right numbers. If something's missing, you have to figure it out. The base area, we already know, 64 pi. Now look at your picture. The mark that they give you here, is that the true height that we want for our volume? Does it go up the inside of the middle? Yes, so that's the one we can use. If it was missing, we'd have to figure it out.
Wait, I got 42 plates. 42 plates.
Okay, look. 402.2. That happens, listen, this is important for you guys to understand. That happens when you rounded earlier. This is less exact because we did the pi button. This one right here is less exact because we did the pi button earlier and this is rounded. It was really 201.06 or something like that. So if you did it your way and did the pi button, this answer is more exact. Okay? The other one's more round. Alright, this one. Let's start the base. First of all, right in this 15 right here, it wasn't given to you and it should be given to you. Because you need to know that this is a, well, you tell me, what would that make this? A square, good. The base is a square, so let's redraw the base as a square. It's 15 by 15. Please write in that other 15. They didn't give it to you, but they should have. Capital B, right? So base area. Okay? Let's do the base area. 15 times 15 makes?
225.
Good.
225.
That's a square. 15 times 15. Now select the formula for the volume that would work for a pyramid like this. What would it be? Good. That's right. Everybody had that right. It's the base area times height, and then it's divided by 3. So we know what the base area is. That's why we always do that work first. Capital B is 225. 225. Height. Is this 12 the true height that we want?
No, it's not.
No. That's right. Okay, that base or that height 12 is on the outside edge. That's not where volume is calculated. Volume is calculated by filling up the inside of it. So we need the height that goes up the inside. Draw that down and call that H. Okay, we need to find this H, and we've done lots of practice with this. Pythagorean theorem will work well here because we know on the sides and we don't know anything about the angles except that this is 90. Alright, what is this side right here? Because it starts at the edge and it stops in the middle where the height was. What would that be?
7.5.
Yes. Okay, that is half of all the way across. All the way across is 15, but the height goes right to the middle and cuts it in half. 7.5. So in this case, what is the hypotenuse? 12. 12 squared equals the other two sides, height squared plus 7.5 squared. So in your calculator, will you add 12 squared plus 7.5 squared, or will you subtract them? Subtract. 12 squared,
It's 9.4.
that's the final answer, minus 7.5 squared equals this, but then you take the square root. And you're correct, 9.4. Now our answer is going to be a little bit rounded because it was 9.3 something. We rounded it to 9.4. If you wanted to be really, really, really accurate, here's what you could do. You could not hit clear on your calculator button. You could leave it at 9.36 and all that, and go ahead and hit times 225 and then divide by 3. Your answer will be better if you do it that way. Those of us that round to 9.4, our answer is going to be slightly off. What do we get?
7.5.
Okay. If you use 9.4, it comes to 705 feet to the third. If you took your calculator, watch this. See how we still have the 9.36? Watch the difference. If I take that now, instead of rounding it to 9.4, if I multiply times 225, and then I hit divided by 3, it's a more accurate answer. It's actually smaller, 702.6. You see why that difference is. It's important that you know that difference. Number 3. The thing about this one is it says to leave it in terms of pi. So we're not going to use the pi button this time. We're just going to leave everything in terms of the pi. And we're going to write everything else around. So what's the shape of this one? Cone. So draw a little cone. It's got to have a circle. It's got to have a vertex. It's got to come down and meet it. Okay, I know that's not good. All right, what is the radius? 5. Now look at the word altitude. The altitude. So when you use the word altitude, they mean that they're giving it to you so that it goes right down the inside, right down the middle, so that you don't have to do the extra work. They gave you the height. Alright, so now the base area is 5. I'm sorry, the radius is 5.
2 pi r
Pi r squared. Area is squared. Circumference is not squared. Alright, so it's pi times 5 squared, what we get? 25.
Oh, yeah.
5 squared is 25, and then it's times pi.
Wait, do you have to time this?
No, they want us to leave it in terms of pi, so pi is going to be part of our answer. Alright, volume. Is this space area times height, or is it divided by 3? Because it comes up to a tiny little point here. It's a cone. Divided by 3. Good. So let's look at the numbers we have. Volume equals base area. Base area we found already. 25 pi. We did that work already. The height. Look at your picture. What's the true height that we need? 23. And then we divide. Alright.
All these people are getting extra credit?
Alright, so please do me a favor and multiply the top first. Tell me what you get. 25 times 24. Don't do the pi yet. 575 pi divided by 3. Now let me give you a little clue. If you add up all the digits of 575, you get 12 plus 5 is 17. Can 17 divide by 3?
Nope.
No, then this number can't divide by 3. That's how you know. Alright, when you get to Algebra 2 or Math 3 and trig and things like that, there's something called radians, and they're always written in this format, so you're going to want to get used to seeing it like this. But on our level, in our tests, you might sometimes see it written with a decimal. So will someone take that 575 and divide it by 3?
Yeah.
And with the pi still there, right?
Oh, yeah.
Thank you. 191.7 times pi still. All that was 575 divided by 3 meters cubed. So both of these answers are acceptable. So, what are the dimensions of this space? Good. So we want base area. That's what everything's about. It's all about the base area and the base perimeter. So what's the area of this one? 16. Formula. Is it this one? Is this okay?
Yeah.
No, because it gets smaller. You divide by 3. Alright, so now all that's left to do is plug in what you know. Do we know capital B?
Yes, 16.
Good. Please remember, capital B means a shape. It's not just a line. Do we have the height that we want, or do we have to figure it out? We have it. It goes right down the inside. That's 5. And then we divide by 3. Does it come out evenly? Okay. Here's 10. So I'm hearing 26.7. Is that what
Well, I
you-
mean, it is something else.
Correct. Yeah. And inches to the